Other than adding and subtracting, we can multiply with complex numbers, and we distribute just like we would normally. And so we have here, we're going to distribute a 4 through. So 4 times -2 is -8. 4 times +3 is +12, and that just has the I with it. So just think about the I as a variable. And then in this case, I cannot combine any like terms, so there's my answer. For letter B, we're going to have to distribute twice. We'll distribute the 2 all the way through, so 2 times 4, 2 times +3i, +6i, and then we'll do -I times 4, -4i, and then -I times +3i is -3i squared. Simplifying then, there's a couple things we can do. We have like terms, +6i minus 4i, and we have an I squared. Remember the very first part of your notes, if you scroll to the first page, we said that I squared is equal to -1. So I can simplify this by replacing I squared with a -1. So that leaves us then with 8, and then +6 minus 4, +2i. And then here we're taking -3 times -1, which is a +3. And then I have one more step so I can combine my like terms that are the real numbers. So 8 plus 3, 11, plus 2i. So watch for this I squared. Never leave an I squared in your answer because it can be simplified to a -1. All right, so same idea here for letter C. 3 times 3 is 9. 3 times -2i, -6i. 2 times 3, 2i times 3, +6i. And then +2i times -2i is -4i squared. So again, we have our like terms in the middle. This time, -6 plus 6, that adds up to 0, and that's okay. And we have the I squared again. And remember, I squared we can replace with -1. So this is 9. And then -4 times -1 is +4. Add those together to get 13. So in this case, we multiplied two complex numbers, I should say, that have the imaginary numbers in them. But because of simplifying, it's simplified down to just one real number, and that can happen. So notice, and we'll talk about this in the next slide, we've got 3 plus 2i and 3 minus 2i. The only difference between these two is the plus and the minus. And last, for letter D, we have 3 plus 2i squared, and this squared is really important. It means we need to write it out twice. We need to write 2 times. And what do we need to write 2 times? We need to write 3 plus 2i 2 times. So here's what that looks like. We would do 3 plus 2i, 3 plus 2i. We're multiplying it times itself. That's what squared means. So please, please, please do not just square here and square here. That is not the same thing. We don't distribute a squared. All right, so now that we've written it out twice, let's see what we get. So 3 times 3, 3 times +2i, 2i times 3, and 2i times 2i, +4i squared. So similar to the last one, except they're all positive here. So combining like terms in the middle, I'm going to keep the 9 at the front, and then 6i plus 6i is a +12i. And then we have again an I squared, so I can cross that off and make it into a -1. So this is 4 times -1, which is a -4. And we'll combine 9 minus 4 is 5, and then plus 12i. And there's our final answer. Then scrolling down here, we talk about complex conjugates. And that is exactly what we looked at in letter C up above. So I'm going to scroll to that letter C again. This is an example of a complex conjugate. because remember we said they look exactly the same. The only difference is we have 3 plus 2i and then 3 minus 2i. So the only difference between those two from letter C was the plus and the minus. When that happens, those are called complex conjugates. And one thing that's true about them is when we multiply them, like we did for letter C, we start with complex numbers, but we end with just a real number. So they think about it as they cancel each other out, so they're no longer imaginary, and they're only real numbers when they're simplified. So for letter A, and here it's listed using A plus BI, A minus BI, same thing. So in here we just want to write the complex conjugate of the complex number. So the only thing that changes is the plus or minus of the imaginary number. The real number stays the same. So here the 6 would stay the same and we do a minus 5i instead of a plus. So the only difference is that plus and minus. So letter B, the only difference is going to be this minus. So I'm going to keep the -2. Do not change that sign. That's a common mistake that's made. The only sign that changes is where the imaginary is. So instead of plus square root 2i, instead of minus here, we're going to do plus square root 2i. And then just be careful. I know it seems kind of nitpicky, but it's really important. This I is not underneath the square root here. So make sure it's not underneath the square root here. All right, the letter C is not an imaginary number. So if you have something that's not an imaginary number, it's like saying plus 0i. So this is the same thing where that root 10 stays the same because it's the real part. And then we could say minus 0i, but we just don't write the zeros. So in this case, the complex conjugate of something that's not imaginary is exactly the same as what it started with. It does not change. And the letter D, we need to simplify first because we have the square root of a negative. So I'm going to break this apart into the negative as being a -1, and then 50 as being the perfect square 25 times 2. Because I know the square root of -1 is I know the square root of 25 is 5, and then 2 will just stay in my answer, or under the square root in my answer. So the square root of -1 is I, that comes out. The square root of 25 is 5, that comes out. I'm going to write it in front of the I. And then the 2 doesn't have a perfect square, it doesn't go anywhere, so it stays underneath the square root. So now, I'm not done. Now I need to write the complex conjugate of that. So if I now have the square root of -50 is 5i root 2. If I want to do the complex conjugate of that, it is an imaginary. So if this is a positive, then the complex conjugate is the negative 5i root 2. So if it's imaginary, we change the sign, like here. If we look at letter C, if it's not an imaginary number, it just stays exactly the same. So that's the difference between C and D. C is not imaginary and D is. C stays the exact same. D, the signs change. So my answer for my complex conjugate is negative there. All right, another thing that these are used for is to simplify when we're dividing. So imaginary numbers, think about them as kind of like their square roots, right? They're the square root of a -1, and we do not want to leave square roots in the denominator. We never want to do that. We want to rationalize the denominator. So for these to help us, if we do not want to leave this the square root of -1, which is I in the denominator, what we can do is we can multiply it just like we would with the square root, except we're going to use its complex conjugate. So if this is 4 minus 2i, we're going to do 4 plus 2i. And then whatever we do on the bottom in the denominator, we have to do the exact same thing in the numerator. That I can be in the numerator, right? Square roots can be in the numerator, just not in the denominator. So then we just need to simplify. Let's see what we get here. So if we distribute in the numerator, remember these are in parentheses, we get 8 plus 4i plus 12i and then plus 6i squared in the numerator. In the denominator, we would get 16 plus 8i minus 8i minus 4i squared. All right, and then now we need to simplify. And when I do fractions, I like to work across because it kind of keeps everything lined up. So in the numerator, we have an 8. And then we also have this 6i squared. And remember, I squared, I'm just going to draw over it, is the same thing as a negative 1. So 6 times negative 1 is negative 6. So I have 8 minus 6, and 8 minus 6 is 2. And we have our like terms in the middle, the imaginary units, 4 plus 12, which is 16. So there's our numerator. It's okay to have that imaginary number in the numerator. And then if we do the same thing in the denominator, this I squared I'm going to make into a negative 1. So we've got negative 4 times negative 1, which is a positive 4. So combining like terms, we have 16 plus 4, which is 20. And then we have 8 minus 8, which is 0. And that's what we wanted, right? We do not want any imaginaries in the denominator. Those add up to 0, so our imaginary units in the denominator are gone. Now there's one more thing we can do to simplify this answer, and that is because all of these coefficients, even the coefficient of your imaginary unit, so we have to look at all three, we can divide those all by 2. So as long as we can divide everything by 2, we can do so, but you have to make sure it's everything. If you had 2 plus 15i over 20, you would not be able to simplify that because you cannot divide 15 by 2. Okay? So it has to be everything. So this would stay the same. Here, though, we can go ahead and divide everything by 2. So I'd get 1 plus 8i all over 10.